on, get your head up.
Thank you. Thank you.
Why are you upside down?
Thank you, Tyrion. Thank you, Brooke. Thank you, Alana. Thank you, Kyson, Rose, Kaylin, Alicia, Zaria. All right, let's get started. Couple of quick notes. All right. I will have your understanding checks and your homework back to you tomorrow so that you can use it to help you learn. We'll probably have a test early next week. I'm sure people have heard by now that we'll use these markers. Okay, so we will be losing a day of instruction this week.
Yes.
No.
Okay?
What does that mean?
I guess we'll find out when it goes public. Okay?
We're out front.
However, okay? Yo, however, we will be having homework.
Uh-oh. You're done. Get out of class.
You're done.
You're done.
Can I talk to myself without people talking over me? Thank you. However, obviously, you will have, it's an e-learning day, you will have an assignment for me. Okay? What it will be is your literacy for all, which you have already done 2 or 3 times up to this point in other classes. Alright, I'm not talking about on Veterans Day. I'm talking about on Friday.
Friday, 16 teachers are out.
I said I am losing a day of instruction. I never was an teacher.
For the playoffs, and they have
So stop. Excuse me, I am standing in the front of the room, and I am talking. I hate being like this, but all eyes on me. Like, it's not about it being about me. However, if you're not looking up here and paying attention, then you are missing out on information. So, you will have your literacy for all from me. You've had it at least once in one class up to this point. If you haven't, we will talk about it. But I find it hard to believe that math, one of the last classes to do literacy for all. There's no way. You have 3 blocks before this class. What do you have first block?
I haven't.
Okay, so for your elective, you already should have done literacy for all.
No,
What
I have a
do
work
you have
note.
second block? What do you have second block? Career prep? Pretty sure you're supposed to have already done literacy for all in there. This is where we read an article and then you write an essay about that article.
We just did that yesterday.
You do it in, hey, stop arguing. That means that one teacher was behind on assigning it, but the window, Kaylin, are you listening while I am talking at the front of the room?
No.
It's hard to listen when you're talking. Quit it. The window for math to do literacy for all started last Monday and it's until this upcoming Friday. So literacy for all is happening this week for us. I will assign it tomorrow. We'll work on it a little bit in class tomorrow, but that will be your e-learning day assignment, and I'm going to go ahead and give it out today. It will be due on Monday. All right? I will be very clear about what my expectations are and things like that when it comes to that. Kyson, please get off your smartwatch or put it up again.
When is the e-learning day?
Bro.
If you don't already know, then you'll hear about it when they call you or email you and your parents this afternoon.
Friday.
Or,
Oh, it's Thursday.
No, that's a holiday.
all right.
So when is it?
You can get it back. That's close.
Wait, then?
Hand it to me right now.
So school Friday?
Electrical.
All right.
Electronic.
Hey, this is a problem where I take 10 seconds to address something and then everyone thinks it's their time to talk. No, that's a time for you to wait respectfully until I get back to the conversation. Now, the other thing I want to say is this. I have 28 students in this class. This graphic organizer was due last Friday. Of the 28 students, only 15 of us have turned this in. 15.
That's how mine is too.
Y'all stop. Stop talking. If you want to talk, you will respectfully raise your hand because The two of you consistently don't productively add to the conversation. Stop. You talk too, Caleb.
I wasn't told that was.
Stop. Terrence, don't talk again until we've had a conversation. From there, this graphic organizer was due on Friday. Up to this point, we have looked at, or until this was due, we had looked at 5, count them, 5 different tasks. One of them was called, what was the first one? Exploring transformations. That was the first one. That one covered translations and reflections. We then did a task that was called reflections and rotations. We then did a task called transformations, translations, and then transformation, rotation, or reflections, and then transformations, rotations. So, when we look at this, should we have only had one lesson under any of these?
No.
No. Every single transformation we covered in at least 2 lessons. And if you haven't looked at all the lessons, you are missing details. There's a reason why I pulled the task that I did. Secondly, and this was not 1 student, or 2 students, or 3 students. This was multiple students. If you are Googling these terms, you're going to hear some words that you've never heard before in my class. For example, a bijective. That is a mathematical term that you don't learn until a college level 300 or 400 level math course.
Physical class, you help me with
Oh, so weird. We're getting these terms that we've never heard of before. Someone who Googled something. Right? Have you ever heard that word come out of my mouth?
No.
Have you ever?
Yes.
Matthew, stop.
You just said
Stop. Okay? From there, right? And that's not the only one. That's the only one that came to my mind off the top of my head. But a lot of us, well, first off, if you had both the front and the back filled out, I knew you Googled stuff because by the time when this was due, we had not even talked about dilations or similar figures. We won't even talk about similar figures until today. So how have you filled this out? Okay, the point, listen, the point of these graphic organizers is that you look back over what we studied, reflect upon those things so that you can learn. It is not copying crap down, it is looking through your notes so that you can learn. Now that does require that you take notes, Rose, when we have a whole class discussion, which to take notes, you got to pay attention when I'm at the front of the room and talking. Consistently, when I'm at the front of the room, pay attention. I give you plenty of time to work within your small groups. That's a time to talk, not in general, to talk about the math. And then when I'm at the front of the room, you pay attention so that you can take notes, you can learn. I get that some of us have off days. I get that there are times when I have to come to school and I'm not feeling well. So I get somebody putting down their head once, maybe every 3 weeks. When it is every day or every other day, or multiple times a week in general, those are called erasers to put on your pencil. Put them back. Sorry. When it is every day or every other day, not to call any students out, and I'm not going to call you out by name, but at the end of the day, it's one of 2 things. It's either laziness or it's you giving up. It's one of those 2. And you got to quit doing both of those. Because here's the thing. If it is you giving up, then you're never going to learn and grow. But I am here to support you, and you have people within your small group to talk with when I'm not in there, or when I'm not in your group. I have designed it so that every group has at least one person that usually works hard enough to know what's going on. Because notice, none of you should know the answer right away. But there is everybody, or every group has at least one person so that if you talk with them, then you can figure out what's going on because they are actively working the whole time. There's no excuse to not try. Secondly, I am all about your growth. So if you don't learn it by the understanding check, cool. You learn it by the test, you're going to be okay. But that requires that you actively pay attention, you actively work, you actively try to learn. Finally, if it's laziness, you're never going to learn being lazy. You can't. Learning takes time. You don't get to just walk out onto the football field and start. Do you?
Yes.
Well, then we need better players because that's bad.
We've been winning these last couple games. So
Don't argue.
Wait, you're telling me that you don't go to practice, you don't lift weights? Oh, you do all those things? So you're telling me you didn't just show up at the football field and just go out onto the field?
Yeah, you did.
Don't argue.
What you trying to say?
he
What I'm
understands.
saying is, someone can't show up on game day and start. They have to put in the work at practice. They have to lift weights. You gotta put in work before game time, correct?
Yes.
I just said that, did I not?
No.
Yes, he
No.
did.
What
He
you
did
just
say
told me was that you
No.
can
Ask
just
me,
show
did y'all
up and
do
start.
practice, did y'all work? I
Unless-
say yes. Did you
Yeah,
say
yeah.
y'all start?
What
I say
I'm-
yes.
it. Stop arguing.
What
I
you
can do
trying to
that
say?
too. What I said at the very beginning that you argued with me on is I said you can't just show up at the game and start. And then that's when you said
Oh,
yes, you
now
can.
I understand what you're
Yeah.
saying.
There you go. See, this is why you respectfully ask questions instead of going like, right? That's not going to help you learn and grow. All right. So from there, my point is this: academics and athletics are the same. Are some people more naturally gifted in the athletic field?
Yes.
100%. However, can everyone work hard and improve their athletics?
Yes.
I didn't say become starters. I said can everyone work hard and improve their athletics?
Yep.
100%. Hard work pays off. That is one of the most believed principles in the athletic field. The same thing is true in the classroom. I'm not saying it's going to be easy. At all. That is not what I'm saying whatsoever. What I'm saying is hard work pays off in the classroom as well. Is your brain going to hurt? Yes. Does your body hurt after you work out?
We be needing a break.
Okay. It's when you go home each day. It's
You
called
give us
Thursday on
more
Veterans
work.
Day.
No.
What are y'all doing right now? Not thinking much, you're just listening. So you get time. Now hold on,
Do
okay?
this for the rest of the day.
No, we're not doing this for the rest of the day. We got stuff to learn. Alright? So what I need you to understand is hard work pays off. And yes, I understand that sometimes we feel like we need a break. However, hold on. The second that I start to give breaks, you're going to ask for more breaks. Yes, that is 100% how the human mind works.
Not me.
And that may not be true for you, but I promise you it's true for people in general, and that's definitely true for people in this class. Also, a break is something you have to earn. I'll be honest with you. Hold up. I would say I have about 4 or 5 students who have earned a chance to have a break. But when I have 28 students, that means I've got 3/4 of my class or more who don't deserve a break. I can't give those 4 or 5 a break. Alright? We got stuff to learn. Now, moving on from there, you need this back. That's yours. Sir.
Nope.
No. We'll talk about it after the bell ringer. So, let's look at this bell ringer. Jeremy, can you hit the lights for me, please? So, what point is the image of -3, -5 after a 270-degree clockwise rotation? So, once again, we seem to be all over the place, but -3, -5 would be here, roughly. All right, that's -3, -5. Before we get going from here, I don't want to do a 270-degree clockwise rotation. What would be easier than that, Alicia, but would still be equivalent? Any idea? All right, so you need to pay attention to this because we're going to have the same question tomorrow, Gabe.
90 degrees, the other way.
So, instead of doing 270 degrees clockwise, you're saying to do 90 degrees
Counterclockwise.
counterclockwise?
Yeah.
No.
Remember hearing that before,
It's
Alicia?
360.
Not really. I didn't know.
I thought you did.
You didn't know the right thing to say?
I didn't know it was a lot of
Okay, but that's what you were thinking? Then say it.
No, it's not playing for I
Okay, so here's another thing though, like, mistakes are your best friend. Like, here's the thing, legitimately, I get it. Have you been ridiculed for not knowing things in the past? Yes. Will other students make fun of you for making mistakes?
No.
Yes, other students will. You will never ever, please hear me very clearly on this, you will never ever ever hear me ridicule you for making a mistake when you're trying. You know the only thing that pisses me off?
Oh.
Yeah, I'll go that far. No, it's not. Terrence. Now, hey, stop.
I stopped.
Listen, Stop. The only thing that will legitimately frustrate me to no end is laziness and apathy. And what I mean by apathy is just not giving a crap. That's where laziness comes in. If you're at least trying, I am more than happy to support you, and I'll even celebrate your mistakes. But like, don't sit there and not try and be like, oh, I have no clue what's going on. Yeah, it's because you're lazy. It's not because it's not being taught. It's because you're not trying. If you don't try, there's no way for you to ever learn. All right? Now, that's not what's happening here, but like, legitimately, try all you want. Make all the mistakes. When you make a mistake, you can grow and learn, and we can all learn from it. Okay? Make all the mistakes. Now, do you hear me teaching right now?
You just okay.
You started talking before I even quit. All right, from here. All right, Brandon. Any ideas what I'm going to do a 90-degree counterclockwise rotation? Like, just give me one part of it. Okay, just give me one part of what I need to do, right? So instead of doing 270 degrees clockwise, we're doing 90 degrees counterclockwise. Just give me one detail I need to know about that rotation. No idea? No. So notice, like, we're here in this quadrant right now. There's nothing you know. Huh? I can't hear you because two students, aren't chilling. Hold on a second. I'll let you answer in a second. I know you got stuff, but I legitimately can't hear them over YouTube. What are you saying? So you think it's going to go over into this quadrant?
No, the other way.
Okay, so kind of, so up here?
Yeah.
Okay, so think about a clock. Which direction is a clock going to go?
That.
Around.
This way? Huh?
I don't know my left or right.
And this is, okay, so this is actually important, right? This is why I celebrate mistakes. Hear me very clearly. If you're trying to talk about clockwise versus counterclockwise as left versus right, it's really confusing. Please do not talk about clockwise versus counterclockwise as left versus right, because it will mess you up, right? Notice right now, it looks like clockwise is going to the left to start, but if I was over here and I was going clockwise, what does it now look like I'm going? To the right. See, mistakes are awesome because now I can address that. Does that make sense why I don't want you to think left versus right? Okay? Instead, think about the numbers on a clock. Again, Anton, it helps to have your head up to pay attention.
I was twisting my neck.
Oh, that's what it was while it was on the desk, right? So think about the numbers on a clock, right? 1, or no, that's not 1, that's 12. 1, 2, 3. So follow the direction of a clock to go clockwise, the other direction to go counterclockwise. Based on that, do you hear me talking? If you want to ask a question, raise your hand. Hold on a second. Based on that, Brandon, do you think I would go this way
Yeah.
or this way?
The first thing.
The first way, right here?
Yeah.
Say it again.
Yeah.
Yeah? Okay, raise your hand if you think I'm going, let's call it direction 1. Raise your hand if you think we're going direction 1. For 90 degrees counterclockwise, are we going direction 1?
No.
We're going direction 2.
We're going direction 2?
Yeah.
Okay, does that help me when I put the 1 versus 2 up there?
Yeah.
So remember, direction 1 is clockwise, direction 2 is counterclockwise. Now, I will point out that 270 would be going in this direction, but isn't that a lot more than just doing 90 degrees counterclockwise?
Yes.
That's kind of the point. All right, Terrence, it looks like you had a question. Is it a question about this bell ringer? Okay, what's your question?
It's about how would I know which way to go?
Like clockwise versus counterclockwise, or the arrows?
Clockwise, counterclockwise, and then clockwise.
It tells you
I know.
270 degree clockwise rotation.
How do you know the degree, what degree to go?
Because it tells you.
Like, no, you're not listening to what I'm saying.
Like, how to go from this 270 clockwise to 90 degrees counterclockwise? Terrence, I'm literally trying to figure out if that's what you're asking. Yes, that is what you're asking. Okay. Can anyone explain to us how we knew that the 270 degrees clockwise was the same as 90 degrees counterclockwise? Gabe, what you got? They add up to be 360. Okay? So notice what you can also do is 360 minus that 270 to know it's 90, and it's always going to be in the opposite direction. Does that answer your question, Terrence?
Yeah.
Okay, so part of it was, that's not the question you were asking. That may have been what you thought you were asking, but that's not what you said. So I was asking more questions to clarify. So getting frustrated. Yes,
Now
Ireland.
that you got all that situated, you go,
Excuse me, I have a student who's actually trying to share with the whole class, which means how many of us should be talking right now?
27.
Island.
How many of us should be talking? Just the one. I didn't hear it. Just stop. You're not even trying to help people learn. Hand me the marker. No, you don't.
I need
You don't hand it to me.
Yeah, I can't make a mark.
You ain't that slick. Alright. So once again, Ireland is talking. So how many of us are talking?
No.
Just one. Just
One.
I'll speak up for you.
Ireland.
Say it.
Ireland is talking. So there's one. Ireland, what were you saying?
okay, now that you have all that situated, now that you go counterclockwise, how you figure out your point?
That's a great question. Anybody know how we figure out that point at this point?
A perpendicular line.
Okay, now be careful. Perpendicular line. What is he thinking about? It's not a rotation.
Straight line.
A reflection, right? So I don't want that. So notice, those of us who said this point right here, that is a reflection across the y-axis, not a rotation. Alright? Does anybody else know what we need to do to figure out our points? Austin? Okay, swap what? The x and the y values. So if it was originally -3, -5, I know the x value is what? Well, but don't worry about the positive and negative yet. After 90 degrees counterclockwise, is the x 5 or is the x 3? It's 5. What did you just say is happening to the x and y? They swap, right? So the x is now 5. What is the y? 3. Alright,
Was that number one?
we're not done yet. So here's what we need to keep in mind. The x is 5 and the y is 3. In what quadrant am I in? The fourth, right? So we know it's starting here, 90 degrees into this quadrant, but I know that x is 5. So 1, 2, 3, 4, 5 to go to this quadrant. And then am I going up or down? Down how far? 3. Based on that, is the 5 positive or negative?
Positive.
Positive is the 3, positive or negative? Negative.
Negative.
That's what you do. So, please notice, and I want to commend a couple of students right now, a few students, Brooke, right, Ren, and Kelsey, you're all doing a great job of taking notes right now based on the discussion we're having. This is a good place to write stuff down.
That's not good to say out loud.
Dude, y'all stop. Like, there's literally a bunch of them right here. Acts like you're in high school. No, get off your lazy butt and grab a pencil. I provided them. Yeah, exactly, lazy butt. So,
Yo, lazy boy.
from here, right, does anyone have any questions how we got this point?
No.
Okay, so you swap your x and y, and then pay attention to the sign based on the quadrant. Yes, Ireland.
The one we just did? Okay.
Remember, what we said is, what's going to happen to the x and the y? No, dude, you don't need tape. Sit down.
I'm gonna get a calculator.
Oh, so
Alright, to get back to Ireland's question,
I said negative.
hold on one second. To get back to Ireland's question, so remember, and that's what I was saying earlier, when we do a 90-degree rotation, right? So we always try to get back to 90. The x and the y flip. So we knew it was 5 and 3 for the x and the y. We didn't know whether it was positive or negative. Alright? But we knew it was in this quadrant. So I knew I needed to go to the right 5 to get into this quadrant. And then do I go up or down? Down. So the x was a positive 5. It was to the right. And then it was down 3, which is why it's negative. That's the coordinate point. The x and the y switch, and then we figure out positive or negative based on the quadrant.
I almost had it.
We'll get some more practice with it tomorrow. Yes, ma'am?
So is 270 degrees counterclockwise the same thing as 90 degrees clockwise?
Hold on, I can't hear you again because students are talking when they should be respectfully listening because you probably have a fantastic question they could learn from. Can you say that one more time?
So is 270 degrees clockwise the same thing as 90 degrees? 270 degrees counterclockwise the same thing as 90 degrees clockwise?
So what do y'all think?
Yes.
That's what you're asking?
Yes.
Yes, yes.
I think it's yes.
They are equivalent. Remember, those two angles add up to be what? 360, and they're going in opposite directions, right? So yes, and that's the beauty is that when we have that 270, I can rewrite it as a 90-degree angle in one of the other direction, and it makes my life easier. Because notice, and that's the point, it's way easier to go from here to here than it is to go all the way around to here. And that's the point, okay?
I just didn't know if it was good.
Yeah, and it's the same in the other direction. Just like, remember we talked about this before, what is equivalent to a 60-degree clockwise rotation?
300 degrees counterclockwise?
300 counterclockwise. Right? So it's the same thing. Right? It always just needs to be in the opposite direction and 360 degrees. So, woo! I feel like it's a lot, but hopefully we learn from it. All right. Any questions before we move forward? Huh? I'll address it in a second. All right. Hey, stop. Stop worrying about it. Stop. Stop. One last detail that I need y'all to hear me very clearly on, because once again I saw this on the graphic organizer, and it wasn't 1 or 2 students, it was probably 4 or 5 out of the 15 who submitted it. You are not doing anything to the X or Y axis. I saw students talking about switching the X and Y axis right here. Is this the X axis? What is that?
The X value.
That's the X value, or X coordinate. Where is the X axis?
0.
So are we switching the X axis at all? No. Be careful about your language. You are not doing anything to the X or Y axis. You are doing stuff to the X value and to the Y value. I heard people, or I saw people talking about adding to the X axis. No, that X axis is what it is. You can add to the X value when doing a translation. Be careful about that. All right, we got to move quicker through these next two because we got math to learn. All right, so I got 0.75, 0.75. Okay, y'all, really quickly. Okay, I need to look back up here. I can tell quite a few of us didn't do it, even though it was 3 questions, shouldn't have taken too long, but what scale factor was applied? Does anyone see any answers that are not scale factors?
Dilated, rotation, side length, whatever.
Yeah, are those scale factors? Nope. Okay, now I will point this out. One of these is a correct descriptor for what transformation happened. Dilation. It was dilated.
I get it.
Right? It was a dilation. Let's look back at the image that I gave you. That was the image. Ask what is the scale factor. Notice, are they the same size?
No.
Definitely not. Bro, there's a blue one here on the inside and a much bigger black one out here. Alright? Quadrilateral is the term we would use for those. So yeah, definitely not congruent. Are they dilated? There's one bigger than the other. Yeah. So the question I asked was, what is the scale factor? Well, I saw at least one person put 54.4. Is this side length a scale factor?
Yes.
Okay, Austin, tell us how you do it.
Oh, crap.
I can tell you how to do it.
Length on the top.
Okay.
Length on the bottom.
So you said image length on the top.
Yeah.
So the image length would be what?
54.4.
No.
And then you were thinking 40.8 on the
Yeah.
bottom. Now, and I'm going to get to what's already said in a second. 1, be respectful how we say it. 2, okay, When you say on top, what is this called for the fraction?
Numerator.
Okay, so you're saying 54.4 in the numerator and 40.8 in the denominator. And so you were talking about this is the image and this is the pre-image, okay? Now, Zaria, you very quickly said nope, which we want to work on how we say that. But why do you say no?
Because it's flipped. It's supposed to be 40.8 is the image.
Why do you think 40.8 is the image?
Because it's the prime.
What do you think about that statement, Austin?
I didn't hear what she said.
Can you say it one more time for us?
It's the prime. A, B, C, D prime.
You see those primes there? So she's saying because those are primes, this is the image. Is that a true statement?
Yes.
Oh, we got small ones.
Can that happen, that it gets smaller?
Yes.
Yes. And so we're going to look more heavily at that today, but yes, I do want you to notice the image is actually smaller in this case. The pre-image is bigger. Now I will point this out because you didn't know this. That is not B prime, C prime, or BC. That's actually the perimeter of those quadrilaterals. So what is my scale factor actually?
0.75.
0.75. That is our scale factor. What do I mean by a scale factor? We should have notes on this. It is that ratio, but what, so remember the ratio is how we calculate the scale factor. But what is the scale
Is
factor?
it like the
It's what
area or
I,
the perimeter of the whole
And when you multiply.
letter?
it's what I multiplied the pre-image by. The scale factor is what I multiplied the pre-image by to get the image. Okay, that's what we want to recognize there. Kelsey, you had your hand up a second ago. What was your question? Okay, let me know after I release y'all to work if you remember it. Now this is important. Is a dilation an isometry?
No.
Wait, I got my question.
What's your question?
So, that number was the, it was the other number?
Oh, I got that.
Those are the perimeters?
Yeah, so it doesn't matter a ton, because remember the ratio of the side lengths is the same as the ratio of the perimeters. But yeah, that was the perimeter of A prime, B prime, C prime, D prime, and that happened to be the perimeter of A, B, C, D.
So the prime doesn't.
Because remember, prime is the image. The primes always indicate the image. Okay? After one transformation, what do we put if it's been two transformations?
That little,
Double prime, right? Two apostrophes. Not, yes, apostrophes. Yeah. Looks like quotation marks, but the double prime is after two. Does that make sense, Ren? Yeah. So the prime is indicating that transformation. So is a dilation an isometry? I got a lot of no's up here. I got a yes. Okay, I want us to look right here though. Yes, because the perimeter stays the same. Did the perimeter stay the same when we dilated a second ago? I mean, think back at what we just looked at. Was the perimeter the same?
We answered this question yesterday on our sheet.
Say again, Zaria.
We answered that question on our sheet yesterday.
Yes, thank you. We did. We literally answered this question on the task. It was the last